Okay, so our topic for today is on fluid dynamics. So fluid dynamics, so as I said, how do fluids flow? So medyo hindi siya ganun kasimple. In general, complicated yan. In general, hindi siya madaling analyze. Of course, there are some basic principles that you can deal with when we deal with fluid dynamics, but these are beyond the scope of the course. So medyo dun tayo sa medyo basic. But for now, let's focus on how to approach the dynamics of fluids. So there are two ways to approach it. So first, uh, we have the so-called Lagrangian description. Hindi lang naman yan, yung Lagrangian description, hindi lang naman yan sa fluids. So, in general and mechanics, ganyan doon. Pero we will not deal with the equations in Lagrangian mechanics. Masyadong mahirap yon, ay masyadong out of the scope na yon. But for the meantime, pwede mong isipin na yung fluid composed of different particles. So, and that particles have some forces acting on it, therefore it has some energy, it moves with some velocity and some acceleration. Diba? So, and therefore, you can determine the individual displacement, velocity, and acceleration of that particle of every parcel of fluid, yung sasabihin nila, parcel of fluid in that fluid column. Pwede mong isipin. So kung may hose ka halimbawa dyan na may tubig, pwede mong tignan yung bawat patsi-patsi o bawat parcel of fluid dyan na nag-flow. And then you can measure the position or the displacement, the velocity, and the acceleration of that fluid. You can always do that. Ang issue nga lang ganito. Of course, after that, you determine the desired quantities of them. Like, for example, energies, kasi may mga energy relations ka dyan, may mga momentum relations ka dyan. Because at the end of the day, matter yan. Ayan. So each fluid parcel has these microscopic conservation principles na fina-follow. Diba? So the point here is you can do that in principle. Ang problema, ang dami-dami yan. Diba? So there's a lot of particles that are considered in this description. Okay, the Lagrangian description is really effective, especially if you want to derive quantities such as conservation of energy and momentum in a certain fluid. Diyan talaga gagamitin mo kasi you are considering the effect of these forces or these momenta or these energies on a certain fluid parcel. Then you just need to generalize it. Dun importante ang Lagrangian description. Okay, so yes, it's equivalent, pero apparently hindi siya ganun kasimple gamitin. So instead of using the Lagrangian description, we can use an alternative, which is this alternative technically, it's another equivalent description, which is your Eulerian description. So instead of looking at the fluid as an individual parcel, so isipin mo na meron kang points. Tapos yung points sa yon, doon ka mag-measure ng velocity at saka acceleration. So, kanina, susundan mo yung fluid particle. Ngayon, mag-stay ka sa isang position, and then, dun ka mag-measure. Dahayaan mo lang na yung fluids dumaan. Okay? Yun yung tinatawag na Eulerian description of fluid mechanics. So, identify the points in space and then observe the velocity of particles passing through each point. So, as an analogy, isipin mo parang nasa traffic. So, what you can do to measure, for example, the velocities of cars in the traffic, you can do two things. So, pwedeng sumakay ka sa kotse, i-measure mo yung velocity ng kotse habang nasa EDSA ka or habang nasa kalsada ka. Or another thing is mag-standby ka sa isang traffic light, tapos tignan mo yung bawat kotseng dumadaan doon, then measure the velocity of each car instantaneously habang dumadaan sila doon. That's the first one is the Lagrangian description. The second one is the Eulerian description. So, the point here is these two are equivalent kasi the Eulerian description will give you the mathematical equations necessary para madaling ma-solve yung equations. Pero yung conservation principles na iaalat doon ay galing sa Lagrangian description. Okay? So that's basically the equivalence of the two descriptions. Pero for now, we will focus on the Eulerian description kasi mas kaya nating isipin yung nangyayari sa Eulerian description. So again, Eulerian description, how does velocity change at every point? Instead of focusing on the individual parcels that are moving in a fluid, we focus on one point and then check how the velocity changes at that particular point. Gawin natin stationary yung point na yon. And then, of course, how does this velocity change through time? And then this velocity is given by this, in other books is capital V, but I'll just write it as small v because mamaya may volume kasi tayo, so makakalito siya minsan. So the velocity at each point is now represented by a field. So in that case, fields na yan, hindi na particles na titiram. You are looking at a more field perspective on fluids, which is defined by your flow field. Okay? So, ganun yung difference ng Eulerian and Lagrangian description of fluid. Question? May tanong ba? Yeah. More on this will be discussed in your higher fluid mechanics classes. This is just a very basic introduction on the two descriptions. Pero I want to introduce this because I think this is important. Okay. So yan. So again, kung di sana ganun ko-complicated ang fluid dynamics, hindi natin kailangan mag-forecast ng weather kasi napaka-hirap i-track down ng mga particles sa isang fluid. And usually, if we don't have simplifying assumptions, hindi siya ganun kasimple. Okay? So yan. Questions? May tanong?
None.
Okay, sige. Now, there are we define some terms related to dynamics of fluids. Kasi dito natin i-base kung anong ibig sabihin ng ideal fluid. Kasi ang focus lang natin for this session is what's an ideal fluid, and doon lang tayo mag-base ng equations natin. So here are some definitions. First, a flow line is a path of an individual particle in a fluid. So as I said, if you use the Eulerian description, pwede mong isipin na meron kang isang point, so meron kang fluid dyan, tapos dumadaan lang dyan yung fluids mo. So meron kang isang particular vantage point, and at each point, the velocity changes in time and in position. So it's a field, it's a vector field. Okay? And when you say it's laminar flow, the flow lines never cross each other, so dire-diretso is a smooth, napaka-smooth ng flow lines mo. So these flow lines are parallel to each other, and it looks like that. So for example, in this figure here, at this yung malapit sa, I'm not sure if this is a chimney or a candle. Let's say candle na lang yan. Doon sa candle na yan, yung malapit doon sa kanyang tip ay laminar yung flow niya. So in that case, the flow lines are parallel to each other, they never cross. However, if it's not the case, then you have turbulent flow. Turbulent flow means the flow pattern changes continuously. So a measure of whether flow is laminar or turbulent is measured by the so-called Reynolds number. Mayroon tinatawag na Reynolds number. Okay, that's a measure of whether the flow is laminar or turbulent. For our case here, we will not focus on turbulence because it's a really complicated topic. Mag-focus lang tayo sa laminar flow. Okay? And then when we say the fluid is incompressible, then density is constant. It doesn't change. It is uniform. So at any given point in a fluid column or in the fluid volume, the density is constant. Hindi nagbabago yung density. So there are a lot of fluids that won't satisfy these conditions here. For example, ketchup. Hindi nagbabago ang density ng ketchup. Hindi siya laminar flow. Diba? But it's still a fluid. So yun, maraming fluids na hindi nag-follow nito. And then finally, we have non-viscous. Viscosity is a measure of the resistance of a fluid to either to itself or to the container. So that's a measure of it can be measured. And then we are only focusing on the non-viscous aspect, or that is there's no internal friction among the particles or among the parcels inside the fluid. Okay? Questions. These are some terms that we need to consider or we need to remember. Okay? Malinaw to?
Yes, sir.
Okay, I hope that's clear. Okay, so turbulence is a really interesting topic. It's a really interesting research topic. But for now, let's not focus on it. Yeah. So bakit ko dinefine yan? Kasi an ideal fluid is defined as something that's first is laminar, meaning of course, it's not turbulent, therefore the flow lines are parallel to each other. They don't cross. Second, it's incompressible. The fluid is incompressible, therefore the density at any given point in the fluid volume is constant. And at the same time, it is non-viscous. We are assuming that viscosity is not present. Of course, in general, it's not true. Okay? So these are the characteristics of an ideal fluid. Tatlo lang yan. Laminar flow, incompressible, non-viscous. Okay? Question? May tanong?
None.
None. So for the rest of the topic of this session, we will only focus on ideal fluids. And as I said, napaka-special ng ideal fluid. Hindi lahat ng fluids ideal. Okay? But for now, let's focus on that. Sige. So the streamline is the path taken by a fluid parcel under laminar flow. So if you have a fluid parcel that's moving, then that particle will take a path, and that path is called the streamline of that particle. And it turns out that for a for a fluid in laminar flow, the velocity is always tangent to the streamline, which makes sense kasi hindi naman nagko-cross-cross yan, di ba? So yung velocity mo at any given point, so if this is the trajectory of the fluid parcel, then we expect that the velocity is also in the same direction as the fluid parcel, or is parallel at least to the trajectory of the fluid parcel. Okay? Malinaw? Malinaw yon?
Yes, sir.
Again, characteristics of an ideal fluid, it's laminar, it's incompressible, and it's non-viscous. Okay, questions? May tanong? Wala?
Too far.
Wala. Okay, sige. Now, let's focus on one of the equations that we will be needing in solving fluid dynamics problems, which is the continuity equation. So ngayon, let's say meron kang fluid na gumagalaw. Okay. Sorry, but before we go to continuity equation, let me first define these quantities here. The mass flow rate is the mass flow per unit area through a cross-section. So, for example, since syempre, fluids are matter, therefore it has mass, they have mass, then at a given cross-sectional area, may so, gumagalaw kang, halimbawa may hose ka, tapos may tubig dyan na dumadaan, or fluid in general, hindi naman kailangan water. Then, there is a certain amount of mass that will travel per time, per unit area. And that is the mass flow rate, dmdt, which is just the density times the change in volume per time. And that dvdt, d capital V, dito acceleration, d capital V, the change in volume per time, is also known as your volume flow rate. The volume flow rate is the amount of fluid with velocity small v that passes through a cross-sectional area given by capital A. So when I write the quantities, I will write this as my volume, and then this, medyo liitan ko, either ganyan or ganyan as my velocity, para hindi lang nakakalito. Kasi nakakalito nga naman, video, rin to, tapos wala namang linya-linya dyan. Okay? Magwalilito. This is volume, capital V is volume, small v is velocity. Okay? Clear? Clear?
Yes, sir.
Tanong? Okay, so I hope that's clear. So again, the volume flow rate is the amount of fluid with some speed v, or in this case, velocity v, that passes through a cross-sectional area A. So the change in volume per time, or the volume flow rate, is equal to just the product of the area of contact times the velocity of the fluid that's passing through it. Okay? And therefore, we can say that the mass flow rate dmdt is simply rho times area times velocity. Okay? Clear? So yun lang naman yun. These are two important equations. Mamaya, medyo nakakalito minsan yung units, pero kayang-kaya yan. So the units, so the SI unit for mass flow rate is kilogram per second. The SI unit for volume flow rate is cubic meter per second. Okay? Wag malilito. Okay, so yun yung kailangan nyo tandaan. The SI unit for mass flow rate is kilogram per second. For volume flow rate is cubic meter per second. Questions? May tanong?
None.
Yan. Okay. So, bakit ko dinefine yan? Kasi, apparently, you can obtain an expression for the continuity equation. So, pwede mong isipin, as I said, we consider a fluid parcel that's moving inside the tube with cross-sectional area A1 traveling through delta x1. So, parang ganito. This is just the drawing in the previous slide. Pero, ang gusto kong sabihin, once that this fluid column here moves some velocity V1, any other point inside this fluid column will also move. Kasi nga, yung density constant, hindi yan magsisiksikan. Okay? Therefore, at any given point here in this fluid column, for example, this fluid column here will also move with some velocity, let's say V2. Doesn't necessarily be the same velocity because it is now dependent on the cross-sectional area. In fact, ang equal dito ay yung volume flow rate. It's the volume flow rate that's equal. So the volume flow rate at A1 is equal to the volume flow rate at A2. Okay? Kasi nga, wala namang nawawalang mass dyan. Okay, matakot ka pa may nawalang mass dyan, di ba? Saan napunta yung tubig? So the point here is, in that case, in steady and incompressible flow, ibig sabihin, walang change sa density inside that fluid, the volume flow rate of the fluid does not change, and therefore the product of the area and velocity at one point in the fluid flow is equal to the product of area and velocity at the other point, at another point in the flow, and that's constant. Okay? Again, the condition here is dapat ideal yung fluid mo, incompressible ang flow. Okay? Okay? This equation in particular, the continuity equation per se is true for any fluid, pero hindi siya ganun kasimpleng form. The simplest form of the continuity equation assumes incompressible flow. Okay? Clear? Clear?
Yes,
Question? So, ang sinasabi lang nito, basically continuity equation is a restatement of your conservation of mass. Conservation of mass yan. Hindi lang natin sinasabi conservation of mass. Pero it's actually conservation of mass. And in general, ganito yung form niya. Okay? That's a more general form of your continuity equation. Well, I won't explain it here. Ang sinasabi lang dito yung del dot dyan ay, ang tawag dyan ay divergence. Divergence operator. U here is some velocity vector and rho here is the density. Okay? So yun. Ang kailangan nyo lang matanda na equation dyan ay ito. A1 V1 is A2 V2. Again, V there is not volume, it is velocity. Questions? May tanong? Wala?
None.
None. Okay. Okay, so just an illustrative example for halimbawa gusto mong magdilig ng halaman. Halimbawa plantito ka pala or plantita, no? So why would you put your thumb over the end of a garden hose? Anong nangyayari? If you put what happens here if you put your thumb over the end of a garden hose? Anong nangyayari?
Lalakas yung pressure ng tubig.
Yun yung term, lalakas yung pressure ng tubig, di ba? So in a way, the velocity of the fluid of the water increases. Kaya mas malaki yung power na mas malaki yung effect niya dun sa kung saan mo nilalagay yung fluid na yon. So in that case, what happens is you decrease the area of the fluid I should say you are increasing the cross-sectional area where the fluid comes out, and by continuity equation, the velocity should also increase. Kasi nga, of course, while it is not ideal in general, that's true. So, ang nangyayari, lumibilis yung velocity dito, lumalakas yung pressure ng tubig. Okay? Questions? May tanong? Wala? None. Okay.